Good morning. How is everyone this morning?
Doing good. How about yourself?
Good, good.
Good.
This rain's pretty nasty, isn't it?
That's horrible. Constant.
I'm not liking it.
No, I'm not a fan either.
Morning, Lindsay.
Morning.
Okay. It went okay. No hang-ups. Did you get the information about the PowerPoint on Brightspace for the you do on your own? Did you get that? It was posted. Did you get the assignment that went with our lesson from Tuesday on statistics? That was posted yesterday as well, yesterday evening. I wanted to allow some time this morning to go over that assignment to see if there were any questions that you may have had on that assignment. Okay, I want to share this assignment with you. For those of you who've had an opportunity to look that over, that assignment, the first part of the assignment, you just had to go through and read the scenarios to determine if it was an observational or an experimental situation. So this represents the answers to that first part. I know a lot of times you folks like to have the answers when you look at your homework to know if you're doing them correctly. So these are the answers. First situation, just for an example, a study to determine whether there's a relation between the rate of cancer and an individual's proximity to high tension wires. That would be an observational situation. If you're looking for rats with cancer are divided into two groups. One group receives an experimental drug. Another group receives a different dosage. They go back after 2 years and re-measure the cancer spread. That is experimental, where you have the two groups and different conditions are being applied. So that just gives you an example of reading a scenario and then deciding whether it was an observational versus experimental situation. The second part of that assignment looked at sampling techniques. So you would read the situation and then decide whether the situation involved which type of sampling technique. So those are the answers to those particular types of problems. So on the second part, we're looking at, for example, the first part where we do a television rating. We're looking at subscribers in selected counties of a state. We're not looking at all the counties in the state, only selected counties. So that is taking particular groups of people in order to look at the questionnaire. So that is a cluster sampling situation. The second situation is where you're surveying every 10th person that comes out of the grocery store. So that's systematic. If the third situation is looking at the television company, looking at the 20,000 subscribers, and they randomly select 1,000 subscribers. That's just simple random sampling. So that gives you an idea of looking at scenarios, looking at situations, and trying to decide how to apply that terminology that we went over. The third problem is just looking at a particular situation and looking at different ways within that situation of doing the sampling. And again, it is looking at the different methods of sampling within that one situation. Not sure why we're having all the ins and outs with the connections this morning. It may be the weather. Okay, on the back of that activity, problem 3 is just continuing. Again, we're on that airplane collecting information and looking at different scenarios within that airplane and how to collect the information. Problem 4 gives you 2 different cases. And from those cases, we're using the vocabulary population, sample, variable, or variable of interest, and method of data collection. And you're reading the case and you're trying to pick out or using that vocabulary that applies to that particular situation. So the first case is about the gardeners, non-chemical methods to control the insects in their gardens. The researchers have designed 2 kinds of traps. They want to know which trap will be more effective. So they randomly choose 10 locations in a large garden and place 1 kind of each trap in each location. And after a week, they count the number of bugs in each of the traps. So for population, what is the population that deals with this particular problem? and we're looking at the insect pest. The sample would be the collected bugs that are in the garden. The variable of interest is the number of bugs that we're trying to get. And the method of collection is experimental or simple random in that experimental method. Does that make sense to you in terms of applying those vocabulary terms that we went over from last class? So this gives you an opportunity to look at how you would use those vocabulary terms in those particular situations. All right, moving on down to part 5. This is just identifying the type of variables, whether qualitative or quantitative. And so when we look at temperature in Alaska, you're measuring that. That makes that quantitative. The make of an automobile is qualitative. Whether or not a 6-volt lantern battery is defective is qualitative. It is or it isn't. The weight of a lead pencil is quantitative because you're measuring that. The length of time billed for a long distance phone call is quantitative. The brand of a cereal that you eat for breakfast is qualitative. The type of book that you take from the library is qualitative. The resident hall for a student in a class is qualitative. The amount of gas that you pump is quantitative. The amount of radon is quantitative. The color of a cap is qualitative. The state that a vehicle is registered is qualitative. So again, you're looking at particular situations and being able to apply your terminology to those situations to identify the types of variables. The last part is getting a little more in depth, looking at the quantitative measurements and deciding whether they are continuous or discrete. Remember, continuous means you're measuring it. Discrete means it's countable. So the length of time until a pain lever begins to work is continuous because you're measuring time. The number of colors used in a textbook is countable, so that's discrete. The number of chocolate chips in a cookie is countable, so that's discrete. The number of files on a computer hard drive is countable, so that's discrete. The pH level in the water of a swimming pool is measurable, so that's continuous. The number of staples in a stapler is countable, so that makes that discrete. So that gives you some more information about looking at variables and deciding in terms of what kinds that they are. So that's just a little review activity that was posted yesterday afternoon in Brightspace for you to go back and work through to help you look at the vocabulary from our last lesson. Anyone have any questions over those particular problems? If you haven't had a chance to do that, that's certainly something you want to spend your time on to work through at this point. Any questions there? Good to go on those? All right, there is another activity that goes with the one that was posted last night for you to work on your own with the frequency distributions. After you look at the online notes and work through that activity, we'll spend some time next class working through any questions that you may have on that particular assignment. And we're ready for today's assignment, okay? Or today's lesson, I should say. Okay, our lesson today is on 2 parts. The first part we're going to look at is measures of central tendency. Most of you will remember this concept from things that you've done from middle school on, middle school math, but we just kind of want to put it all together. When we talk about measures of central tendency, we're talking about measures from the center So we're trying to find where the middle of the data is. And we want to try to find that middle of the data for various reasons. We may want to find the middle of the data because we want to know what was most typical. We may want to find the middle of the data because we want to find an average. We may want to find the middle of the value because we want to know what is the most frequent value. Can't spell this morning. Q-U-E-N-T. What is a balance for the data? What's an overall balance to make the middle? So all of these are questions or reasons for finding the middle of the data. So what are the measurements that we use for central tendency? Of course, the mean is one that you've heard of before. This means that you're going to sum up the values and divide by the number of items. That's briefly just what a mean is. You sum up all the values and you divide by the number of items. Median, you've heard of before. It is telling you the middle value of the numbers. Mode, you've heard of before, which means it's the value that occurs most frequent. One you may not have heard of before is mid-range. So that may be a new one for you. And this is just going to be your minimum value plus your maximum value divided by 2. So there are 4 values that constitute measures of central tendencies. Now, in terms of statistics, we do go in a little more in depth and we look at some specific formulas. So we're going to start with the mean. A lot of people refer to the mean as the average, but some people also refer to the average as any of these central tendencies. So we kind of have to watch that term a little bit and how we refer to that. The formula looks like this. We have X with a bar over it equals this funny looking symbol with a little X divided by N. So in order to understand the formula, the first thing is you need to know what the symbols mean. So the X with the bar over it means that that is the mean of a sample population. The little x means that is a data value. That funny looking symbol is a Greek letter called sigma. But the meaning of it is to do a sum. And then the little n means the number of data values. So if we know what the symbols mean, when we go back and we look at this formula, we can interpret what it's telling us to do. The mean of the sample will be the sum of all the data values divided by the number of the data values. So it's kind of like shorthand. If we know what each of the symbols mean, it is in shorthand telling us what to do. So the mean is a quotient of the sum of all data values and the number of data values. Quotient means you're going to do division. Now, there is also another formula that you're going to see that's going to look like this. Now, it doesn't look a great deal different. It's got a few different symbols. This funny looking symbol is another Greek letter and it's called mu, mu, where the sigma is the capital. This is a lowercase mu. And it means population. So the X with the bar over it means we're doing the mean of the sample, where the mu means we're doing the mean of the population. And if we're doing the mean of the population, we're doing it exactly the same, but instead of using a lowercase x for the data value, we use a capital X for the data values. And instead of using a lowercase n, we use a capital N to be the number of data values. So basically, it's the same formula, just written a tiny bit different. So let's look at an example. This set of data represents the number of days off by non-workers. And we want to find the mean. So using our formula, we would add all of these values up. And divide by the number of items. So when we add them all up, we get 276. So having your calculators out handy. You're going to need your calculator a lot today with our examples. What is 276 divided by 9? Anyone got an answer for me? Surely someone can pull out their calculator and work this out for me. $276 divided by 9 would be what?
30.6 repeating.
Okay. 30 point what?
Sorry, 30.6 repeating.
I'm sorry, I can't hear you very well.
30.6 repeating.
Okay, 6 repeating. Now we need to round that. So we're going to round it to the 10th position and get 30.7. As a general rule, you will round 1 digit beyond the data. So our data is whole numbers. So when we do this calculation, we round 1 digit beyond the whole number, which is to the 10th place. If it had came out to be a whole number, obviously you can't round it beyond that. So that it would be what it is. But in general, that is the rule, to go 1 digit beyond, or 1 digit beyond what the data is. If our data had been to the 10th place, we would have rounded to the 100th place. Okay, so you've done mean before many times. That's not anything new to you. Just the symbols are a little bit new for you in terms of not having seen maybe those symbols before. One of the things that I would suggest for you for this particular unit is to start yourself a formula sheet. Just one sheet where you put the formulas on. So you kind of have that sheet as you're working problems to refer to just the formulas. All right. Median. Median does not have a symbol. No special symbol anyway. When we're finding the median, which is the middle value, the first step is to always arrange your data. Well, we don't need 3 R's. In numerical order. Least to greatest. That should always be your first step. So we're going to use the same set of data, our workers, and we're going to find the median for those workers. So we want to arrange that set of data in numerical order first, least to the greatest. So as we go through our data, our smallest data item is 20. And when you're arranging it, sometimes it's easy if you just mark it off so you know that you've accounted for that value as you're arranging it. The next smallest value is 23. The next value in the list would be what? Anyone? 24. and then 26, 30, 35, 36, 40, and 42. This set of data has an odd number of items. So when you have an odd set of numbers, you have your number of items divided by 2. And so your middle value, you're going to round up. So in this case, we get 9 divided by 2, which is 4.5. So the 5th item is the middle value. 1, 2, 3, 4, 5. The median equals 30. So if it's odd, there will definitely be a middle value. Only one answer. Now let's add 18 to our data list. That means it's going to go in on the bottom side. We still would arrange the items in numerical order, but this time we have an even number of items. We have to find the average or the mean of the 2 middle values. So n divided by 2, in this case, gives us the 2 middle. So 10 divided by 2 gives us 5, and then we also use the 6th item. So 1, 2, 3, 4, 5, and 6. The 2 middle values. Do you have to do this little calculation? No. You can just count and figure out what goes in the middle. That's up to you. Now, how do you find the average of the 2 middle? You add them together, divide by 2, and so 28 is the median. Now, I'm sure this is old stuff. Everybody's done that before, right? We've done mean and median before. Mode, the value that occurs most often. The thing to remember about mode is there may be more than one mode. Or there may be no mode. If there are two modes, we use the term bimodal. If there are three modes, we use the term trimodal. If there are more than three, we say multimodal. In this example, what would the mode be? Does any value occur more often than the other? Every item only occurs once, right? So that would be no mode. What about this example? Does any data item occur more than another item? They all occur more than once, but they all occur the same number of times. So what would you say about the mode? It is still what? No mode, because no item occurs more than the other mode or more frequently than another. What about this set of data? We have items that occur more often than others. We have 18 that occurs 3 times. 20 only occurred once. 30 occurred more often. It occurred 3 times. Let me use a different symbol for the 30. $32 occurred more often. Are there items that occurred more often than others? Yes. So the mode would be 18 and 30 because both of those occurred more often than the other values. So it has more than one mode. In this case, it would be a bimodal situation. Does that make sense? Gives you some examples to go by. Okay, mid-range. This is the calculation for most of you that you probably have not seen before. This is the average of the lowest and highest value no special symbol. We found it by taking the min value plus the max value and dividing by 2, or the lowest plus the highest, ever how you want to write that. So if we go back to our example of the number of days worked, the mid-range would be the lowest plus the highest divided by 2. Which would be 30. Now, how do you know when to use which? If you need to use all the data, which one would you pick? Which calculation involved every single item? The mean. Which one gave you a balance point? For the middle. That one is the median. Which item gives you a quick estimate of the middle? That would be the mid-range. If you were looking for similar values, what's typical of the values? You would use the mode. So depending on what you're trying to find out, maybe which measurement you would pick to choose to find that information. Just because you want to find the middle does not mean you always find the mean or you always find the median. It may involve thinking about other things about that calculation. Now, we're going to start into doing some grouped data, doing the same calculations, but doing it with group data. And we're just about at an hour. So I want to go ahead and take our break here, and then we'll come back and start on the group data calculations with the measures of central tendency. So if we'll go ahead and break here and then come back and look at the group data and doing the calculations. Okay, so about 10 minutes, we'll see you back. Okay.